Part of the thing that you're going to have to do here is solve a triangle, because eventually we're going to put context on these triangles and they're going to mean something to you. But right now, the goal is to be able to solve a triangle. Now, what does that mean? Great question. So glad you asked. When I ask you to solve a triangle, that means you're going to find the measures of all of the angles and all of the sides of the triangle. So I'm asking for 6 things when I'm asking you to solve a triangle. 3 side lengths, 3 angles. When we are drawing a triangle and it uses the phrase in standard position, which most of these will, this is how you're going to label them. Do you notice something about the letters in this triangle? They match with each other. What kind of letters are on the outside? Lowercase letters are going to represent the side lengths. Uppercase letters are always going to represent angles. So in triangles, when you have problems, if it gives you lowercase, that's a side length. It gives you uppercase or a Greek letter, that's an angle measurement. And the A goes with A, big A with little a, big B with little b, big C with little c, and C is always your hypotenuse.
Are you sure?
Yes. So one of the things we're going to do is solve the right triangle with no context. But here we go. I prefer that you always draw an image. So if you come around and ask me for help on something and you have no triangle drawn on your paper, I'm going to tell you, ooh, draw your triangle, because a lot of your questions are going to be answered by drawing your triangle. It says solve the right triangle ABC. So here we go. I know that C is always by hypotenuse, so I know that side length C is going to be across from big angle C. Doesn't really matter how you label the rest of these. We will call this big A and little a, and then big B and little b. Things I know from the given is that big A is equal to 34 degrees 30 minutes. Yuck, don't love using degrees, minutes, seconds when we're working with a triangle. So what is 34 degrees 30 minutes in decimal degrees? 34 degrees 30 minutes in decimal degrees. 34.5 degrees. So we know that is the angle A. In fact, I'm going to go ahead and label angle A as 34.5 degrees. If that is unhelpful to you, another way you can label these that a lot of people find easier, my numbers get really small, so I don't always do this. You could put it inside the triangle since it's an angle, if you prefer that. The other thing we're given is that side length C is 12.7. So this side length C, my hypotenuse, is going to be 12.7 inches. I don't recommend putting this one on the inside. Inside should be your angles, and this is a little c, so it's representing a side length. Our end goal of this problem is to be able to list big A, little a, which we already have big A, big B and little b, big C and little c. Now, this is almost too easy, but you should know one more angle measurement. Which one do you know?
Big C.
Big C. What is big C? 90 degrees. And then, like, if we just use the concept of triangles, can we find out big B?
Yes.
Yes, because all triangles should add up to what? 180. So if I'm finding big B, I can find big B by doing 180 degrees minus angle A minus angle C. And if you do that math real quick, that's 180 degrees minus 34.5 degrees minus 90 degrees, which, yes, gives you 55.5 degrees. Yes?
Why didn't you put down little c if we already know that? Are we turning this again?
Oh, you're so right. We do know little c. I just missed it. Thank you. 55.5 degrees. Now, again, I like to add things onto my images as I go because sometimes that's helpful, especially when you have a composite image together, like that one question everybody asked me about from 2.1 where there's 2 triangles smushed together. Was it just you? Don't look at me like that. Okay, I like to add things to my image so that I know how much they are when I know them. That might be something you like, maybe it's not, whatever. We have big A and we have big B. We now need to use one of the angles we know and the side length we know to set up a trig function that can solve for one of the other side lengths. I prefer that you use the angle given instead of the angle you got, because eventually these might be decimal values and you would have used a rounded number. Use the one they gave you. So compared to this angle, let's find side length A first. Compared to the pink angle right here, is the little a opposite or adjacent?
Opposite.
Opposite. We know the hypotenuse. So which trig function uses opposite and hypotenuse? Sine. So we can find and set up a sine of big A should be equal to little a over c. That's the opposite over the hypotenuse.
Oh, is this what you were trying to say for that one?
Yeah. So here, if we do sine of A, we're doing the sine of 34.5 equal to something, I don't know what A is yet, divided by 12.7. How do I solve for A? Yes, multiply or cross multiply, same concept, multiply on both sides. You eventually get that little a would be equal to 12.7 multiplied by sine of 34.5. Ooh, I forgot my degree symbol, degrees. And boom, that's something we can throw in our calculator. But for today, you were usually given a 30, 60, or 45 angle, so you used your table at this point. But now we're just wanting approximations instead of exact values. So what is 12.7 times the sine of 34.5? Right, so we have 7.19, we'll round that to 34, and that is the value of A, 7.1934 inches. Again, just pay attention to how the questions want you to round, because it will tell you. Okay, we have A. Great, I'm going to add that to my image because I like to do that, 7.1934. And now mathematician's choice. We get a little bit of variety in how we solve for the last one. You can either solve for little b by using Pythagorean theorem or setting up a quick another little trig function. I recommend the trig function because you used a rounded number for your pink number. If that was like a cute number like 5.5, Pythagorean theorem is great. But if it's a rounded number, you might lose points in specificity of your decimals. So we're going to also set up another trig value that helps you solve for little b. Compared to the angle they gave you, so still comparing it to A. B is the adjacent, correct? We still know the hypotenuse that was given to me. Which function uses adjacent and hypotenuse? Cosine. So if we set up cosine of angle A, that should be equal to little b over c. We fill in what we know. We know angle A is 34.5 degrees. We don't know little b, so we leave it as a variable, but we know that C is 12.7 inches. Same math is required here to solve, so that's nice. You multiply both sides by 12.7, so that B is equal to 12.7 times the cosine of 34.5 degrees. And beep, 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 bop, that's a calculator question, which if your calculator already answered the first one, press up, press enter, change the sign to a cosine, boom. What do we get here?
10.4664.
Nice. So now we know little b is 10.4664 inches. And since we have all 6 measures, we have the entire solution of the triangle. What's up, Joseph?
So like all the other numbers only have like 1 or 2 after the decimal. Can we just round it to where it is 1 or 2 after the decimal if you have the exact number?
Depends on the question. Just read to what it wants. We're writing down extra decimals in our notes because it could be the 10th place, it could be the hundredths, or it could be the thousandths or 10,000ths. Just depends on what the question itself is asking. Thank you for asking that question. Huh? Of course. Can we try another one?
No.
We're going to anyways.
I forgot there was more.
Now there's a typo in this question, so I need you to make sure that you change this. This was a big A, but it's supposed to be a little a.
That's a little A.
It's a little a. So sorry. And I know it's little a because it says centimeters. Big A would have been degrees. That's on me. Okay, same vibe. We're going to solve the entire triangle, but this time we're going to be given two sides instead of a side and an angle. But always we draw a triangle for ourselves because it's very helpful to know what we were given and what we need. We'll have A. This one, that's the 90 degree, is C. Then we have big B. Little b is across. Little a is across. Little c is across. Guys. Again, I like to label what we already know because it's helpful. We know that side length A, little a, is 29.43 centimeters. And we know that the hypotenuse C is 53.58 centimeters. Do we know any of the angles? No, so we're going to have to use maybe something else to solve to find the angles.
Yeah, but C is 9.
But what?
C is 9. Big C is 9.
Oh, good point. Big C is 90. We do know one of the angles. Okay, so I'm just going to set up my little answer sheet here. So we have big A, big B, big C. We knew that one. Little a, little b, and little c, which we know some of these. Okay, my spidey sensors are going off that if I know two of the three sides of a right triangle, that I can use Pythagorean theorem to find the other one. And since I don't really have an angle that returns helpful information for me, like I know we could do trig with the 90 degrees, let's just go ahead and show the Pythagorean theorem on this problem so that you see an example of when we can use that. So if we set up Pythagorean's theorem, a squared plus b squared equal to c squared. Oh, nice. Those are the exact same letters we just used. Our legs are a and b, hypotenuse is c. If we fill this in, we'd be having a lot of digits rolling around. So before we actually fill it in, let's solve the equation for what we're missing. What are we missing here? B. If we solve for b, it would be like b squared equal to c squared minus a squared. What's the last step to solve for b? Square root both sides. And since this is a distance, I'm only going to take the positive square root. We don't need the negative because it's a distance of a triangle. We wouldn't measure things in a negative unless we were adding direction. And so boom, we can find the b value by plugging in the numbers for c and a. B would be equal to the square root of 53.58 squared minus 29.43 squared. Thank goodness we have a calculator. Go ahead and type that in. And we're going to again round to 4 decimals, please. Very good. All right, so we have the b value is 44.738 centimeters. We have all 3 sides. Hooray. I missed a number. Let me slide another 7 in there. All right, now we need to do something inventive to be able to solve for one of the angles. Which angle would y'all like to solve for first? Big A or big B?
Big A.
Sure. All right. Big A. We need to pick one of the trig functions that we have to solve for big A. Which one do y'all want to use? Sine, cosine, or tangent?
Sine.
Sure. We have all 3 sides of this triangle, so the world's our oyster here. If we set up the sine of A, the sine of A is always going to be the opposite over the hypotenuse. What letter is opposite there?
Little A.
Little a. What is the hypotenuse?
C.
Little c. So if I fill in what I know, I would say sine of A, I don't know it yet, is equal to 29.43 over 53.58. What am I searching for again in this problem? Big A. Big A represents a what? Angle. In the notes before this, what did we do to solve for the angle when we had the value? Inverse sign. Very good. So we're going to use the inverse sign here to say that the angle A would be equal to the inverse sign of 29.43 over 53.58.
33.3171.
Yeah, so we get angle A is 30, I lost the number on my paper, 33.3171 degrees. So boom, we have A. We can find B the easy way or the hard way.
Easy way, please.
Easy way. You have 2 of the 3 angles of this right triangle. What should a triangle add up to? So how do you find that missing angle? Add everything, subtract from 180. Or if you're writing a formula for it, you would say angle B is equal to 180 minus A minus C, which you can do the math for that. What does angle B end up becoming? Yes, 56.6829 degrees. And then voila, we have our entire setup of all 6 numbers that solve this triangle. So on these 2 examples, the first one you were given a side length and an angle, and the fact that it was a right triangle, so really 2 angles. And so we have steps up for that one, but if you were given 2 of the 3 sides, you still have steps to solve it. Questions, comments, concerns?
Are we done?
No, of course not. We have more application. We have touched on this vocabulary in the last section with the car question. But when I'm talking about what's called an angle of elevation, what you're looking at is basically if you look straight out from your eyeballs and then look up a little bit, the angle compared to looking straight versus where you're looking is called an angle of elevation. It's lifted. Yes? Yeah. An angle of depression is the opposite. So if you're looking straight out from your eyeballs and look down, that's an angle of depression from where it would be straight out to where it goes down. So in these problems, you're going to be given a scenario that you have to decide what the picture looks like before we start to solve the trig things. So look for these words about angle of elevation versus angle of depression. If it's angle of depression, those are the ones students get wrong the most often, so just be careful. We'll see examples of both. Okay. When we're doing these kinds of problems, the step I always want you to do is draw a sketch. Like I said earlier, if I see no sketch drawn, I'm going to make you start there. Should always have a picture of the scenario or the triangle involved and label it with the given information. Label the quantity to be found with a variable, and I prefer a variable that makes sense for the problem. So if you're finding height, maybe h. If you're finding length, maybe L. If you're finding distance, maybe T. If you're finding, I couldn't think of another example. Label it where it makes sense. Step 2 is use the sketch to write an equation that relates the given conditions, the given quantities, to the variable. It's probably going to be sine, cosine, or tangent. Solve the equation and check that the answer actually makes sense. So here we go. No laughing at my inability to draw things, okay? It says at point A, which is 130 feet from the base of a flagpole, the angle of elevation to the top of the flagpole is 26 degrees, 40 minutes. Find the height of the flagpole. So here's what my example might look like. This is the flag. Haha. It says at point A, which is 123 feet from the base of the flagpole, an angle of elevation to the top of the flagpole, which means from here upwards, that angle is 26 degrees, 40 minutes. Find the height of the flagpole. What letter should I use in this problem?
H.
H. So we're trying to find the height of the flagpole. Boom. We want to know this height. How does that H look so funky? Okay, there's a couple problems with this problem. First of all, can we use this angle in our calculator?
No.
No, so what are we going to have to do?
Convert it
To
the degrees.
decimal degrees.
Yeah.
Yeah, get it out of degrees, minutes, seconds, so that it's in decimal degrees. And then we need to figure out a way that these things I know are related. Let's just go ahead and guess. Let's take care of this. What is this angle in decimal degrees?
26.666.
0.667. I just put another 6, 7. Okay, we know this angle in decimal degrees now. 26 2/3 basically. What is the trig value that we have that relates this angle, this side, and this side? Sine, cosine, or tangent? It's tangent. Compared to this angle, this is the what? Opposite, and this is the, which is tangent. Okay, cool. So if I set up a tangent, I would say that the tangent of the angle A would be equal to the opposite over that 123 feet. Okay, so if I'm doing the tangent of angle A, which is 26.667 degrees, equal to h over 123, how do I solve for h? So we know that h will be equal to 123 times the tangent of 26.667. This is exactly like we did in the triangle problems. It just had application to it. So your setup is a little bit of the tricky part to make sure you've drawn your picture correctly. If you've done it correctly, there should be a triangle somewhere. In your calculator, what does this equal?
61.7738.
Should be 61.7738. Again, just worrying about whatever the rounding says on your notes or on the homework. Last example for today until you're done having to listen to me talk. It says, from the top of a 210-foot cliff, David observed a lighthouse that is 130 feet offshore. Find the angle of depression from the top of the cliff to the base of the lighthouse. Okay, here we go. Here's the cliff. Here's the little dude sitting on top of it. Thank you. And it says that he's looking at a lighthouse that is 430 feet offshore. So if I look 430 feet this direction, there's a tiny little lighthouse. And I'm just going to draw a house because I know it's not a lighthouse. You get the idea. It's a house. I'll put like a little light on top. Is that better? That's worse. I hate it. I'm backing up. I erased it before you could take a picture. Okay. Find the angle of depression from the top of the cliff to the base of the lighthouse. So remember, from the top of the cliff to the base of the lighthouse, we are looking for this angle.
That one?
That's an angle of depression. Depression should go down from the horizontal looking down. So from the cliff looking down, we're looking for that angle theta. Oh, I forgot what number. How tall is my cliff? Yeah, I should have labeled that. My bad. Okay. Interesting. So my image doesn't feel like the angles are inside the same picture, no? Let's think back to topic like 1.2. If this line and this line are parallel, then this angle and which angle are the exact same? If this are parallel lines, which they are, the horizontal and the horizontal, this one is congruent to what angle? Yeah, what is that vocabulary? Starts with an A and then an I. Oh, there's 3 words. Alternate interior angles. They are on alternating sides of my transversal. They are interior angles. Guys, this angle is the same thing. Which now all of those shapes are on the same side of my triangle that have the numbers. So compared to this angle, what is this side? Opposite, adjacent, or hypotenuse? And this one is? So guess which one we're using again? Tangent. So if we set this up, the tangent of our angle theta will be equal to the opposite, which is 210, over the adjacent, which is 430. I'm going to make this pink just because I can. Okay, weird though, because how do I solve for my variable here? What is my variable here? Theta. How do I get theta out of tangent? The inverse. The way you get an angle out of a function to isolate it is the inverse. So if we were solving for theta, theta would be equal to the inverse tangent of 210 over 430. Okay, Calculator time. What is the inverse tangent of 210 over 430?
96.
So we have that the angle of depression that this guy, what's his name, David, is observing the lighthouse is 26.0296 degrees. I have an inkling that at some point your homework, though, is going to ask you not for your answer in decimal degrees. Be prepared to send it back to degrees, minutes, seconds. Look in your notes. I think it's 1.1 has the conversions of going back and forth between degrees, minutes, seconds, and decimal degrees. All right. You have the rest of the class period to work on your homework. There were 2 sections today, so there's 2 separate homeworks that have opened up online for you.
Are they